Okay, guys, lesson 1.2. We are looking at properties of real numbers. So, up through your math career, up to this point, everything you've talked about has been real numbers. And for our time being, everything we're going to talk about is going to continue to be real numbers. It's later, I can't remember if it's later second semester or the beginning of, later first semester or the beginning of second semester that we learned something called imaginary numbers. But for right now, everything we're talking about is real numbers. Now, I'm going to label this whole picture, diagram here, is going to represent real numbers. Now, real numbers are broken into two categories. Real numbers either are blank or blank. Do you remember what those two categories are that real numbers can be broken into? Well, it's not a category, though. We'll talk about square roots, but what? Rational or irrational. There we go. So all real numbers fall into the category of either rational or irrational. So I'm going to label this top part on the left rational, and this right part irrational. So all real numbers fall into either the rational category or the irrational category. Now, what do you remember about rational numbers? Fractions. Okay. Official definition of rational numbers is anything that can be expressed as a fraction. Okay. So anything that can be expressed as a fraction is one of our definitions. Now, if we're talking about it, another way to say rational numbers are decimals that what? Right? They have to be able to turn into a fraction, which means they do one of two things. Nope, not yet. You're ready for that square root, aren't you? Okay. They're going to be decimals that either end, as in terminate, or decimals that repeat. Okay? So I'm going to put a definition for rational over here, and then we'll go through some examples. But rational numbers can be written as a fraction. And in parentheses, I'm even going to put down here, repeating or ending decimals. I ran out of room. So anything that can be written as a fraction is rational. Those rational numbers include decimals that either end, as in terminate, or repeat. What are some examples of rational numbers? Give me a rational number. 2. Can 2 be written as a fraction? Yeah, because 2 can be written as 2 over 1, right? So 2 is the example of a rational number. What else? 4. 76. Okay, so any type of whole number can be written as a fraction, right? Is rational. What else? What are some other forms that are rational? I mean, can I include something like 2/3? 2/3 is a fraction, right? So since it is a fraction, that definitely makes it rational. What about the decimal 0.25? Can I include that? Yeah, first of all, it's a decimal that ends. But also, what do you know about 0.25? It can be a fraction. Like what? 1 over 4, right? You can start with 25 hundredths, but 25 hundredths reduces to 1/4. So a decimal like 0.25. That works. Could it be negative?
No.
Why not? Can fractions not be negative?
When they can.
Nope. Negatives can be both places, rational and irrational. So we could have a negative. For instance, I could say negative 3.4. Because what is that? That's negative 3 and 4 what? Tenths. Negative 3 and 4 tenths, and we can make that into an improper fraction, right? Okay. The one thing I haven't mentioned, a repeating decimal. For instance, 0.3 repeating. That's rational. You guys may not know it, but to take a single-digit repeating decimal and make it a fraction, you just put over 9. So 0.3 repeating is 3/9. Now, you guys probably know it better as what is 3/9 reduced to? 1/3. So you might know 0.3 repeating to be 1/3. Okay, those are all examples of rational numbers. Anything can be expressed as a fraction. Okay, what's it mean to be irrational? We defined rational to be anything to be written as a fraction or any terminating or repeating decimal. Okay, so now our irrational is a decimal that does not end and does not repeat. Okay, so these are the things that can't be made fractions. So I'm going to write this out as non-ending, non-repeating decimals. Yes. Yes, I can try and do that. And I'm wondering if that one's actually on here, but you can still see the screen, right? Okay, because last period I had a situation where a student, like, my icon came up and it was just a black screen with my circle there. And so she's like, where are the notes? And so, okay, so you can still see it, it's just blurry for whatever reason. Okay, yeah, I will, it appears to get done right after school, unfortunately, just because I have a meeting after school, but I will try and get a picture out to you. I also plan to put a video on Schoology, so that could help too. Okay, back to irrational. What's a good example of irrational? What's our favorite example of irrational? Pi, right? When we talk pi, we talk 3.14, but is that what pi really is? Something like that, right? Okay, 3.14159, and then she stopped. But yeah, it's something like that. Okay, now, we've got one more good type example of irrational. What'd you keep saying earlier? Square roots. What kind of square roots are irrational?
Negative.
Nah, well, could be negative or positive. Are all square roots irrational?
The ones that haven't been.
Okay. Yeah, ones that aren't perfect squares. If I say square root of 25, square root of 25 is 5. That falls over into our rational category. But what if I say square root of 2? Do you know the square root of 2?
I know square root of 4.
Okay, but square root of 4, again, the square roots you know are going to go over to the rational category. Something like square root of 2, that's a big, long, messy decimal. You punch square root of 2 into your calculator, you're going to get one of those decimals that fills the calculator screen. And those are the irrational types of numbers. Okay? Okay. So, all real numbers either fall into the category of rational or irrational. Now, you'll notice we have some subcategories under rational. And the first subcategory is integers. Any remembrance of what integers are? No? I like to think of integers as all of your positive or negative whole type numbers. So if I'm talking about positive or negative whole type numbers, 1, 2, 3, 4, and on the flip side, -1, -2, -3, -4.
So every integer cannot be a decimal or fraction.
Right. Integers are not going to involve those decimal and fraction parts. Now, you can either write positive and negative whole numbers, or what I tend to do here is just write some examples. So -3, -2, -1, 0, 1, 2, so on and so forth. Those are your integers there. Okay, your positive and negative whole numbers. And all integers fall into the rational category. All rational numbers fall into the real category. Okay, next subcategory of integers, whole numbers. What about whole numbers? What? They're going to be whole. Which part of integers do they not include? Right, they can't be negative. Whole numbers are just the positive, and whole numbers start at 0. Okay, so whole numbers start at 0. So 0, 1, 2, 3, so on and so forth. And we've got one more subcategory, very similar to whole, but it is called the natural numbers. Natural numbers? Any thoughts there? Very similar, there's only one difference.
Not 0.
Not 0. Okay? Natural numbers, if you have any little kids around you a lot or living with you or anything, when they start counting, what do they start counting at? 1, right? They don't start counting at 0. We don't even start counting at 0 normally. You start counting at 1. And so these are often referred to as the counting numbers. But it's just 1, 2, 3, 4, so on and so forth. Must be positive, must be whole, and does not include 0. Okay, so those are our categories of numbers. I can guarantee that's not the first time you've heard any of those words. I'm not guaranteeing you remember those from the past, but those are things you've been introduced to before. And we're going to use those to answer some of our first questions here. Your school is sponsoring a charity race. Which set of numbers best describes the number of people who participate in the race? So using the words we just talked about, what set of numbers do you think would represent that answer? Sierra? Whole numbers? Miles? Natural numbers? Maggie? Integers? Okay. So Sierra, why whole? Okay. She's going to argue that you could have nobody signed up, or you could have 1 people, 2 people, 3 people, so on and so forth, right? Okay. Miles, why natural? Okay. So he's going to take the argument of there's going to be at least 1 person participating. Okay. Maggie, why integers? Okay, so what's negative 2 people look like? But is negative 2 people a thing is my point. Okay, so I am going to veto integers just because we can't talk negative people. For the same reason, no one said it, I'm going to veto rational numbers. Because rational numbers, not only do they include negatives, though, rational numbers also include fractions, decimals. Can you have a decimal portion or a fraction part of a person? No. Okay, so that takes us back to whole or natural. I'll be honest. I would accept either answer there. I mean, the difference is 0. Okay, in my answer key, I have written down natural, just because I was going to go with the idea that number of people who participate makes it sound like it went to me. I'm going to argue that at least one person participated. But on the flip side, I would not count whole wrong in this situation, because I totally understand that as well. And I've had both answers all day. Okay, so I'm going to write down natural numbers. And it does not ask for an explanation, but if you want to put an explanation down, just as a reminder, I mean, the key is that we cannot have negative or parts of people. Hello? Yeah, you could probably do that. Bye. Maggie, Mrs. Cook would like to see you just for a second. Okay, so what I wrote down there for my explanation with natural numbers is that you cannot have negative people, a negative amount of people, or parts of people, aka fractions, decimals, not happening. Okay, the bottom one there. If each participant made a $15.50 donation to a local charity, which set of numbers best describes the amount of money raised? What do you think, Emily?
Rational.
Why rational?
That is a decimal, but stops
Okay. So because it's 1550, anytime you have something that's going to end in that 0.5, we have to be able to include decimals, right? Decimals that end, and so rational. Could we say irrational here? No, because those are big, long, messy decimals. We're talking money. At most, you're going to have 2 decimal places here. So I'm going to say rational here. And my reasoning for putting rational numbers is that I need to include decimals. Okay, so make sure you have written down however much you want to write down there. And we're going to move on to problem 2. Problem 2 asks us to plot these numbers on a number line. Now, when you get to homework tonight, I think there's numbers 5, 6, 7, 8. Ask you to plot numbers on a number line. We're going to do it. My recommendation when you do it in homework is to take all 4 numbers and put them on the same number line. You don't need to do a different number line for each one. Just like what I'm going to do here. So we have negative 5 halves, square root of 2, and 2.6 repeating. How high and low is my number line going to have to go? I mean, positively, we have to go at least up to what whole number? 3. And then negatively, I don't know if you figured it out yet or not, you're going to have to go down to at least negative 3. So I would like this, set up one number line in homework and just put all of your plots on the same one. Negative 5 halves. How do we know where to graph negative 5 halves? What are your thoughts on negative 5 halves? What do you think?
I divide -5 by 2.
Okay. Okay. So if you do -5 divided by 2, you get what decimal? -2.5, right? Okay. And even if I just divide that by hand, 2 goes into 5 2 times with a remainder of 1 over the denominator of 2. So that's 2.5 or 2.5. Okay, whether you do it by calculator or by hand. Where is -2.5 on this number line? Yeah, it's going to be in the middle of -2 and -3. Make sure you do go past -2, though. I'm labeling that with a -5/2. You can label something like that in homework, or if you want to just put the problem number, like problem 5, 6, 7, 8 in front of it, that would work too. Okay, square root of 2. Can you figure out where square root of 2 is before you grab your calculator? I know, I'm being mean. I'm making you try to think without the calculator. But square root of 2, can you at least narrow it down to what two numbers it's between? What do you think, Miles?
In between 1 and 2.
Okay, in between 1 and 2. Because the square root of 1 is 1. And we know it's bigger than the square root of 1. But the square root of 4 is 2. And we know it's smaller than the square root of 4, right? So it's got to be between 1 and 2. Does anyone happen to know it? Or did you calculate it? Square root of 2 is what? 1.4? I know 1.414. That's as far as I know. Okay, so yeah, it goes on past that. But the square root of 2 is between 1 and 2, a little bit closer to 1. And 2.6 repeating. Where's 2.6 repeating go? Yeah, in between 2 and 3, it's going to be a little bit closer to 3 than it is 2. That was kind of an easy one there. So, as I said, on homework, you can do all one number line. That's fine with me. Now, on this next question, I'm going to challenge you to talk through it with me without your calculator. Okay. How do the square root of 17 and 3.8 compare? Use inequality symbols. So we're looking for like a less than or greater than type answer. Talk to me about what you know about the square root of 17 not using your calculator. Square root of 17. What are you thinking, Whitney? Okay, so if I think about square root of 17, I know that that is really close to the square root of 16. And the reason I'm talking about the square root of 16 is because I know the square root of 16, right? The square root of 16 is 4. So square root of 17 has to be bigger than square root of 16 because it's a bigger number. If square root of 16 is 4, that means square root of 17 has to be bigger than 4. What do we know about 3.8 in relation to 4? 3.8 is smaller than 4, yes? So if one of these numbers is smaller than 4 and the other number is bigger than 4, can we compare them without using a calculator? Definitely. Now, officially, the original problem was given as square root of 17 and then 3.8. So if we keep them in that order, the inequality symbol needs to be a greater than, because square root of 17 is greater than 3.8. When you do the homework, I kept mine in this order when I put my less than or greater than symbol in. Now, could you flip this entire problem around and write it the other way, though? You can. You could also say that 3.8 is less than the square root of 17. That is equally correct, as long as you put the pieces in there. Now, if you're just going to put a symbol, you have to go with the given order there. Okay. One more in this section. How do the square root of 26 and 6.25 compare? So what comes to your brain when you think square root of 26? Square root of 25 comes to our brain, yes? Okay, well, let's see what happens. Let's see. The square root of 26 has to be bigger than 25, square root of 25, yes? Or square root of 25 is less than square root of 26, which either way you want to say it. What do you know about the square root of 25? It's 5, right? So at this point, I'm at the situation where I know the square root of 26 is slightly bigger than 5. What's our other number? 6.25. Well, what else do we know? 6.25 is bigger than 5. And the square root of 26 is bigger than 5. Does that get us anywhere? Not really, because in this case, both our numbers we're talking about, square root of 26 and 6.25, they're both bigger than 5. Now, we all fell for the same trick. And I'll say, when I first did this problem, I fell for the same trick too. Square root of 25 isn't the square root we really want to think about. What's the square root we really want to think about instead? Miles?
Square root of 6.
Not what you really meant to say.
Oh, yeah.
Square root of 36? Because the square root of 36 is going to equal 6. Is 6 more helpful? Yeah, because I'm going to have, well, I guess I better not say it. So if we talk about square root of 26
Point interruption. Can I have your attention
versus
for a few
square root of
minutes?
36.
If you are interested in being student council, sign-up forms can be picked up in
I'll
Mr.
finish that
Penn's
explanation in a
room,
moment.
room 118. Interested in learning more about World War II and military history? Then join the World War II Scholars Club today. See Mr. Wilson in room 203. The first meeting will be Thursday during homeroom. Attention, all vocational students who go to vocational, then come to Tri-Central. Starting tomorrow, you will come into the office, sign in, and then sit on the auditorium steps or the bench out there until the bell rings. You're not allowed to go to the hallways or your locker until the bell rings. Please see Kylie Tharp in the high school office. Hear ye, hear ye! All good scholars reports room 106 today. Oh, you already did that. I'm sorry. Any high school boy or girl interested in playing soccer, please stop by the office to sign up. Reminder, there will be a mandatory meeting for all EdPro students during homeroom A and B this Thursday. Meeting is in the high school library. Good luck to the volleyball team. They will be at Taylor tonight at 6 o'clock in lunch roll. All athletes, quick reminder, please wear your mask to and from the athletic facilities. To be clear, the only time you're not wearing your mask is when you are physically playing the sport or practicing. Away games, you need to wear it to the bus, on the bus, and into the away school. You need to wear your mask in the locker room, to your sport, until you start practicing. Also, if you lost your watch, please come to the high school office. And I need a 9 or more set to the high school office, please. Thank you. Have a great evening.
Okay, those are really long announcements today. Okay, let me finish up what I was saying about this one in that square root of 36 is 6. Since 36 is bigger than 26, that means 6 is slightly bigger than square root of 26. We also knew that 6.25 is bigger than 6, right? So now that's what we needed to know. One of these numbers is smaller than 6, one of these numbers is bigger than 6. And so we can say that the square root of 26 is smaller than 6.25. Okay? Now, the part that I'm running out of time for, and I've got about 2 minutes left, so give me just a little bit more time. You have a list of properties down here, yes? And there's a couple examples on the back. I'm not sure we're going to get to those today, but these are the properties you're going to be using to answer questions in homework. Okay? For instance, commutative property. You've seen the commutative property before. It's the idea that 3 plus 4 is the same as 4 plus 3. Okay? If you're answering commutative property, then that would be commutative property of addition. If it was something more like 4 times 5 is the same as 5 times 4, then you're going to use the commutative property of multiplication. Okay? Associative, that's the one where you have 3 things added or multiplied, and you can move the parentheses. Identity property, that's how do you add or multiply to get the same thing. So how do you add to get the same thing? You add 0. How do you multiply to get the same thing? You multiply by 1. The inverses, what do you do to get that identity? So you have to add a number and it's negative to get 0. You have to multiply a number and its reciprocal to get 1. And then the distributive property, you guys know that one, right? We'll be using that here in a couple of days, but you guys know how to distribute, I think, at this point. You take that A and multiply it in. Okay? So, I'm not going to mess with the examples on the back at this point because we are kind of out of time. But, homework. Did you write it down? It's the workbook page again, right? And Liz, it's in Skyward in case you didn't catch it. But it's the workbook page. But are you doing the entire workbook page? No. 1 through 20, and then 29 and 30. And that's listed in Skyward. Okay? You do not have to, I think there's 34 problems on this workbook page. You're just doing 1 through 20 and 29 and 30. Okay? It's what's right there above files. Got it? Do that for tomorrow. And let me know if you run into problems, okay? You got what you need, Liz? Okay. I will try and get you a picture sent later on, okay? Okay. Have a good day. Bye. So much for that being quick, Maggie.
Yeah.
Well, I don't know when it comes to the high school office.
She had so much to do for my schedule. Because I had 2 study halls, and I'm not supposed to. And I needed to be putting in art and his